There's a new kid on the block in the realm of continuous delivery and DevOps called platform engineering. I confess, I'm not really a fan. I'm always open to be persuaded, and in this particular case, skepticism is a bit weird from my point of view, because I've often led or worked as part of teams that we'd probably call platform engineering teams. I also often recommend the use of platform teams to help the organisations that I work with to transition to continuous delivery. But the problem here is that I think that platform engineering is an idea that's being poorly communicated. And I'm nervous that people are taking completely the wrong message from that communication. So what is platform engineering, and why am I quite so sceptical? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe. And if you enjoy the content today, hit like as well. Platform engineering is not very clearly defined. And I think that's for a good reason. I think it's trying to rebrand something that has been around forever as something new and cool, without recognizing or acknowledging what we're really talking about here. This is what one website currently says promoting this idea. So does that mean things like operating systems, the concept of directories and files perhaps, build scripts, automated deployment and configuration maybe, databases and messaging systems, or the compiler for my programming language? Come to think of it, the programming language itself. Where do we draw the line? Are we saying that the job of a developer is only to type code in their programming language? I hope not. There's a lot more to software development than that. This seems a very naive, overly simplistic view of software development to me. This sounds like a description written by a marketing department, impressive sounding words perhaps that are fundamentally meaningless and conceptually useless. The idea of the cloud is to make things simpler, not more complex. Cloud technology in general raises the level of abstraction for the provisioning and maintenance of infrastructure, but it doesn't really add more than what was there before. I'd argue the point about architecture being more complex now than before too. More complex than what? The internet? That's a 1970s idea. The web? 1980s. Distributed systems perhaps? Well, that's 1960s and beyond really. Software has been around for a while, and we've solved some pretty complex problems during that time. Let's not get too carried away, shall we? Let's pause there for a moment and say thank you to our sponsors. We're fortunate to be sponsored by Equal Experts, Tricentis, Transfic, Sleuth and IcePanel. All these companies offer products and services that are well aligned with the topics that we discuss here every week. So if you're looking for excellence in continuous delivery and software engineering, then do click on the links in the description below and check them out. All of this is not to say that things are the same now as they were in the old days. They aren't. But the difference is not that systems have become more complex to build. They're bigger, sure, and that can bring its own problems, certainly. But most modern systems are bigger by virtue of doing more of the same kinds of things that early distributed systems have always done, solving the same kinds of problem using the same techniques that were developed in those early days. There are some very difficult problems that crop up when we start dealing with distributed software, and modern systems didn't invent these problems, nor most of the solutions to them either. I'm thinking of the demons of concurrency, distribution, fault tolerance, and the most complex problem of all perhaps, managing and coordinating state in software running in multiple places. I point these things out in this video because I think that they're all deeply relevant to what makes modern or any other systems hard to design. So these are exactly the kinds of complexity that ideally we'd like our platform teams to hide from us. But we'll get to that later. I think there are two main reasons why modern systems are more complex, and neither of them is new. One is trying to build software more quickly by having more people, And 2 is dealing with the problems of distribution that we've just mentioned. Scaling in technical rather than team terms is really only ever tricky because of the second category of these problems, the distribution problems. If the information never joins together, we can give everyone their own local copy and leave them to it. That's easy. If not, we have to deal with the complexity of bits of the system failing while keeping the system as a whole working, coordinating shared access to state, dividing up the compute, or all 3 of these things, or any combination of them really. These are the things that cause the real complexity. Until quite recently, the book that I'd recommend to help with the first problem, that of scaling development, is this. Written in 1970 by Fred Brooks, and still as true today as it was when I was a boy. I'd still recommend that you read it, but now we have something else important to add to the reading list. And I think that this is probably where the people currently promoting platform engineering may have got their inspiration from. Team topologies. One of the team types in the team topologies model is that of a platform team. The other source of complexity, that of dealing with the distributed systems, is always and fundamentally difficult in ways that are impossible to avoid and often difficult to hide. Distributed systems are dramatically more complex than single user or single process systems. And they're challenging because of these fundamental problems, which are inherent to having information and processing in multiple places. These things aren't even specific to information in computers, let alone specific tech. Having 2 or more copies of the same information in any form is always a more difficult problem to deal with. It's probably true that more teams are now being asked to deal with systems like these than did before. So it's probably now less the realm of experts in distributed systems than perhaps it used to be. We had ways of hiding some of these problems in the past, transactions and relational databases, for example. But another place where modern software systems are more complex is that we have outgrown the limitation of some of these models for very large systems. Their abstractions leaked. They didn't scale. So we need to find ways of coping with these very complex problems that always existed and make that easier for most people to deal with, in the way that databases and transactions did in the past. So that people with less expertise in these sorts of complications can deal with it and cope. This is what the cloud has helped us to do in part. Often by using and commoditizing many of the techniques that were pioneered many decades ago. The cloud offers more canned expertise than existed for many of these problems before. The problem is that we don't have an alternative generic kind of solution that simplifies the programming model for nearly everyone, as we did in the past. The result of this is that the amount of stuff that needs to be considered to do a good job of a modern system is certainly daunting, but it's always been daunting unless your application fit into the overly simplistic but very helpful model of things like databases with transactions. Software development is a complex thing to do, and it's very difficult to hide from that fact. Sure, you can start off writing simple single process, single user systems on your own. And it's pretty easy to learn what you need to do to build systems like that. But as soon as you start working with other people, adding concurrency and distribution, and the complexity explodes, and it takes knowledge and expertise and a degree of smartness in the way in which we organise ourselves and approach our work to do a good job for these kinds of systems. We need guide rails, but I think that the concept of platform engineering, as widely explained, attempts to duck this problem by making it seem like it's somebody else's problem. And I think that's either a very naive and poor strategy or an essential one, but one that is at once what we've always done and harder than it looks. Why naive? Well, the stuff that I've read sounds like it's focused primarily on tools and their complexity of use. My paraphrase is, all this stuff's complicated, so we don't want you to think about it all of the time. The solution's easy. Have a platform team of experts to worry about the complex tech for you instead. I don't think that ever works. This isn't a problem of tools and technology, this is a problem of design. You hide the complexity by creating your own abstractions. You encode your version of the complexity in a way that allows people to use it without worrying about all of the detail all of the time. In reality, this is much more complicated than letting somebody else do it for you though, because that's what the cloud providers are already trying to do for the generic stuff. The reason that the tooling for distributed systems is complicated is because distributed systems are complicated in a whole variety of different ways. What this means is that there is no cookie-cutter one-size-fits-all solution for any of us. So the choice of your platform is deeply, inherently, fundamentally tied to the problem that you are trying to solve in the design of your system. It's an important part of the design of your system. It will often be helpful to have the assistance of people that understand different technology if you don't, when you need it in your platform. But the tech alone is never sufficient to define a platform team. This is the problem of software design and software architecture writ large, no more and no less. Unless we're building crap systems, this has always been part of the design challenge for a new system. Cookie-cutter approaches like the relational database model are great for problems that fit them, and still make a sensible choice if you only have a few hundred or a few thousand users and a problem that fits a relational database. But the problem of system design is making these choices. And good systems design means abstracting your choices so that you don't have to worry about every last detail all of the time. But this is a very difficult thing to do well, and dividing your teams up by the tooling that they know doesn't even come close to solving this problem. The idea of platform teams from team topologies is a very good one that I've talked about here before. And part of the definition of a platform that the team topologies authors used was that they should be aimed at reducing the cognitive load in stream-aligned teams. This is good stuff. And they should be provided in a way that from the perspective of those stream-aligned teams, they're self-service. The stream-aligned team chooses when and how to use them. These things help because they help in structuring our organisations so that the platform teams avoid the commonest mistakes of ivory tower engineering or dividing work up into absurd technical layers. I worry that the advice that I've read on platform engineering promotes both of these anti-patterns. The saving grace is that they also add the caveat that the platform services should be self-service. My real nervousness with platform engineering is that it presupposes a degree of expertise and maybe even correctness first time that seems, if not unlikely, probably impossible most of the time to me. I think that platform engineering describes what things look a bit like when everything goes well, rather than defining a strategy that helps you to achieve good outcomes. Platform engineering is fashionable at the moment. It's often mentioned as a more modern alternative to continuous delivery and DevOps. I'm afraid that I think that this is complete rubbish. Gartner writes that platform engineering is trending because of its promise to optimize the developer experience and accelerate product teams' delivery of customer value. Sorry, but I think this is too grand by far. This is not a strategy. It may be a useful tactic sometimes, and for that it must be well applied, if it is to help at all. When misapplied, it can be a disaster if the coupling is too tight between these different technological breaks. The difference between a good application of this tactic and a bad one is back to what I was saying earlier, good system design and architecture. My point here is not to diss the idea of platform teams. And some of the stuff written on platform engineering is mostly restating that, which is a good thing. But rather to point out that the way that you get to great platforms is to evolve them from the demands of stream-aligned teams. Yet platform engineering is often couched in terms that read to me as a more like a scary traditional sounding magic bullet style advice. Throw all this hard infrastructure stuff over the wall to this team of experts, and then your software will be easy to write. For example, this article from Software Engineering Daily says, platform engineering causes the traditional responsibilities of a site reliability engineer to shift. What rot! These are completely unrelated concepts. If you'd like to see more about what I think about good strategies for team organisation are, check out my free how-to guide. There's a link to that below. This may be all the result of semantic diffusion, where the real aims and goals of platform engineering are being misunderstood, miscommunicated, misinterpreted, or even missold for commercial reasons. But I think that this is largely being communicated as a bad take on a good but very, very old idea as far as I can see. The problem is that the hype cycle demands new buzzwords to feed the hype mill, and this has become one. I think it's important by design, both architecturally and organisationally, to manage the complexity of the systems that we build. A key part of that is to identify lines of abstraction that separate the concerns of different parts of the system from one another, so that we don't need to worry about the detail of what's going on behind those walls of abstraction. Whatever the size of the team, it's good to recognise and to draw these lines in the code. Using modularity and cohesion, and by managing the coupling between the systems and components. These lines of abstraction, once identified, can provide useful demarcation boundaries between teams. But identifying them is part of the process of design and architecture, and so is also part of an iterative process. My point here is that this is an organic design problem. Your first guess will invariably be overly simplistic or just plain wrong. I don't think that you can ever do a good job of creating a platform unless you deeply understand the problem from the perspective of a stream-aligned developer. As soon as you move people to be dedicated platform people, and particularly if you limit their thinking to expertise in a particular technologies, you run the risk of detaching them from that most important system design perspective. So separate platform teams aren't always the best answer. Conversely, if you have a large organisation with lots of developers with little experience of the problems of creating and managing build systems, pipelines and deployment, or sensible designs for common services, infrastructure as code and scalable systems, I'm not convinced that you can hide all of that complexity from them easily. Best to start small. Make and try out these decisions with a small group of people, usually more experienced people, and grow the platform and tech and teams more organically as you learn enough to start to identify your good abstractions. There's a trade-off. Sure, you can provide crude, generalized abstractions that skate over some of the complexity, but these abstractions always leak. All abstractions leak. And that may or may not matter to you. But in reality, this is the low-code trade-off. If you can live within the abstraction and deal with the inevitable constraints that it places on your design and implementation choices, then fine. But how easy is it to spot when you cross over from fine to this is now a big problem? The trouble with all of this is that the design of abstractions that successfully hide complexity is a very difficult problem. To my mind, this is what the history of software design is really all about. This is what we do. Imagine that we want to provide a platform that makes it easy to create an account. We could create a platform team to look after the common account services, perhaps. They provide simple REST API that we can call to create an account when we want it from any application. Later, one of the stream-aligned applications is involved with some finance industry stuff. And for that, in order to be able to comply with money laundering regulations, they're required to add, know your customer checks of some kind to make sure that we know who it is that we're dealing with. What does the platform team do now? We could leave this as a problem for the finance application team, but now they don't benefit from the platform at all, and we lose single sign-on for all of the users because they can't access the finance app and finance users can't access anything else. Or we could add this new behaviour to the platform, and now every other service has to go through the KYC checks too. And every app has to change in step, or we have to make it optional. My point is that this is not a technology decision. So talking about platform teams as technical teams is the wholly wrong model. Here's a description of what most platform teams do. Here's another. This is the same old message from the 1980s at a different level of abstraction. What this take on platform engineering is saying is, we'll look after all of the opsy and technical stuff for you. Well, that simply doesn't work for my example, or for any team doing anything beyond the very, very simple. The rubber really hits the road when we get back to the complexity of distributed systems again. You can't hide this stuff without a lot of sophistication in design and implementation. In my Know Your Customer example, what if the KYC check takes 3 days? Whatever the original abstraction, remember it was presented via a REST API. That API no longer makes any sense, and you'll very likely need a significant change in the protocol between the platform and the application to abstract this in a way that different applications can use it consistently. This is now going to be a whole conversation or series of conversations, even at the level of the application. This is not really a contrived problem. This is how real-world systems evolve. Dividing by technology doesn't address this problem, let alone solve it. This kind of change can throw all sorts of assumptions into question. Is REST still a good choice? Should I simply support a whole new API for account signups that need KYC, and so on? My point is that there are system design decisions at play here, not just technical, and certainly not technology-specific decisions. Platforms and platform teams are a useful tactic. They can be a very effective way to organise work to help scale development. But actually, this is only exactly the same design choice that you make if you don't separate them out into a platform team too. The extra step of making the platform self-service from the stream-aligned perspective is a useful team decoupling mechanism. It certainly helps. But achieving this level of separation of concerns is not easy, and will take time and iteration for it to evolve and stabilise. I'm certainly not against the idea of platform teams. I'm not even against what I think are the goals of platform engineering. But most of what I've read on this topic so far is wrong, and in my opinion, likely to lead people to suffer the same old problems of siloing development and expertise. My advice is read the Team Topologies book on platform teams. Practice continuous delivery and good engineering practices to manage the complexity of your systems. And don't buy the hype that this is some kind of grand new approach to software development. Thanks for watching, and I hope that you've enjoyed this episode today. If you enjoy our stuff on the Continuous Delivery channel in general, please do consider supporting us and joining our Patreon community. Thank you again.